Welcome everyone to this series of lectures on outer joins. So as I mentioned, there's a few different types of joins, and one of the subsets of these types of joins are outer joins. And there's actually a few different types of outer joins. Outer joins essentially allow us to specify how to deal with values only present in one of the tables being joined. And these are more complex joins than the simpler inner join, which is essentially the default join, where you only grab rows present in both tables. So definitely take your time when trying to understand these outer joins, especially when we start talking about left and right outer joins. So in this series of lectures, we're going to start by talking about full outer joins, which is the simplest outer join, and we'll also add in the clarifying where statements you can add in order to specify what actual rows you want even further. And then we'll go into a lot of detail about the left outer join, which is probably the hardest for beginners to grasp. And then we'll also add in clarifying where statements to subselect rows from a left outer join. Once you understand that, we'll just quickly go over right outer join, since it's essentially the reverse of a left outer join. And if you understand a left outer join, you pretty much already understand a right outer join. It's just the opposite. But let's not get too carried away. Let's begin with the full outer join. So let's start with the full outer join. Now let's review the two example tables from the previous lecture series on inner joins. Recall we have these registrations tables and this logins table, where we have people registering for a conference, and then depending on whether or not they showed up or if they registered, we have them log in on site. Here we have Andrew, Bob, Charlie, and David, or A, B, C, D. They registered. Logins, Andrew and Bob show up. They're present in both tables. However, we have Xavier and Yolanda. They forgot to register, but they still showed up and logged in anyways. Okay, so we know we would join these tables together on the name column. Again, in this little universe, we're going to assume that the name is a unique identifier. There's no such thing as two Andrews or two Bobs in the world. And recall, using that inner join that we learned about previously, we could match Andrew and Bob in both tables. However, keep in mind we have names that only appear in one table, and that is Charlie and David in registrations and Xavier and Yolanda in logins. So let's see how the different outer joins deal with this particular discrepancy. We're first going to take a look at the simplest, which is a full outer join. And this actually might be even easier to understand than an inner join. So an outer join, or a full outer join, just grabs everything. So the syntax is select all the columns from table A, do a full outer join of table B, and then on wherever that column match occurs from table A equal to table B dot column match. And it's essentially just grab everything, whether it's present in both tables or present in only one table. Notice that it doesn't really matter again if table B and table A order is switched here, because this is completely symmetrical. So because this Venn diagram is symmetrical, you can switch off the table order because you're going to grab everything anyways. So let's take a look at this. The actual syntax here would be select all the columns from registrations, perform a full outer join on logins on registrations.name equal to logins.name. So let's actually see how SQL thinks about this in the background. First, we're saying grab everything from the registrations table. So I'm going to have to first make this just font-wise a little smaller so we can fit in the results table. And we're going to fill in the results table the way we can think about this. We're saying grab everything from registrations and a full outer join on logins. So we fill in first everything from registrations. Again, we don't really need to worry whether or not they're in table B or table logins because we're grabbing everything anyways. So we fill in with Andrew, Bob, Charlie, and David. And then we're doing a full outer join on logins, so we need to start filling information for where we actually have a name match. And we know we have a name match on Andrew and Bob, and then we fill it in with the corresponding login ID. In this case, it was number 2 and number 4. Now the issue we arise with is that we didn't have a Charlie or David in logins, but we're still asking for everything. So what SQL ends up automatically doing for us is filling this in with null, essentially clarifying to you that there was no value there present. So there was no Charlie or David in the logins column. And since this is a full outer join on logins, we also need to fill in the rest of logins, which was Xavier and Yolanda, and then the corresponding null values for the registrations table because they were only present in the logins table. So this is what it would look like to do a full outer join on these two tables on the name column. We grab everything and then fill in for null values where we only had a row present in one particular table. So this is the easiest outer join to understand because you're essentially just grabbing everything. Now the next thing I want to quickly discuss is qualifying a full outer join with a where statement. And we can do this in order to get rows unique to either table. In other words, rows that are not found in both tables. Essentially, this is the exact opposite of an inner join. Let me show you why. The way this works is we say the following. We'll say select everything from table A with a full outer join on table B on table A.columnMatch is equal to table B.columnMatch. That's what we had last time, and that filled in the entire Venn diagram, including the intersection. However, we're going to add in a where statement to qualify it a little further. And this is going to add in the statement where table A.id column is null or table B.id column is null. So that essentially means that we're looking for the actual values where one of the table's ID columns is null or the other table's ID column is null. Essentially the opposite of an inner join, because this will only grab things that are unique either completely to table A or unique to table B. Keep in mind, notice here I could have switched the order from table A to table B because this is again symmetrical right down the middle. So what does this actually look like in our example? We'll say something like select everything from registrations, a full outer join on logins, on registrations.name equal to logins.name, and then we can specify where registrations.this registration ID is null or where logins.login ID is null. So this should show you how this would actually work. This is what we had last time. This is a full outer join. And notice here we have null values for our registration ID and null values for our log ID. Technically, we could have done the checking of null on name as well, but we're just going to use the ID column here. And what we're going to do here is we'll specify grab them where there's only null values for that. So look here, we're going to add in where registrations.regid is null or where logins.logid is null. Essentially, you can think of this as adding in a where statement after you've already done the join. So you're just further filtering. You're going from this full outer join table and then specifying find me where those ID columns are null. And that essentially removes those first two rows, which was the match for Andrew and Bob. And now this is going to show us the results that are unique to only table A or only table B. We no longer have rows that can be found in both tables. Essentially, the exact opposite of an inner join. So let's see a quick example in pgadmin of full outer joins, as well as adding in that qualifier. Okay, here we are at pgadmin. Let's imagine that some new privacy rules have been implemented, and we want to make sure that we don't have any payment information that's not attached to customer, or that we don't have some customer information that isn't attached to any payments. Essentially, we want to make sure that all the payments we have is associated with a current customer, and all the customers we have are associated with some historical payment. We don't want to have some customer ID information for someone that's actually never purchased anything in any of our rental stores. So that's the new privacy update. We're just kind of imagining the situation. So what are we actually going to do here? We can say select everything from payment just to get an idea of what we're working with. We have again this payment ID and this customer ID. And I want to make sure that essentially all the payments here are associated with a current customer, and if I select everything from customer, that these unique customers are associated with some sort of payment. I don't want to have any customer here that hasn't actually made a historical payment. So the way I'm going to do that is I'll say select everything from customer and do a full outer join with payment. And just as before, we're going to say on, we'll say customer dot customer ID equal to payment dot customer ID. So because this is a full outer join, that's just going to take everything and join it together. So essentially, this is every single row found in every single table. So again, it's everything from customer and everything from payment. But recall the new privacy idea that we wanted to implement was to figure out, make sure we don't have any information that's essentially unique to payment, not associated with customer, or unique to customer, where we for some reason have customer information like their email when they've never done a historical payment. So that means I want to perform an additional filter with a where statement. So I want to check where on my customer table that customer ID happens to be null. So we'll say where customer ID is null. We can put that in lowercase. Or where payment ID is null. All lowercase there. So what is this actually saying? It means we're going to fully join the customer table and the payment table where those customer IDs join up. And now I'm going to filter it to attempt to find rows that are either only unique to the customer table, meaning we have information about a customer that's never made a payment, or only unique to the payment table. Notice here how I'm using the payment ID, which is a unique identifier for the payment table. If we keep going over, we can see here every single payment has this unique payment ID. And if I run this, notice I get back empty results, which actually means we're in compliance with this new privacy policy. We don't have any payment information not associated with some customer, and we also, more importantly, don't have any customer's email information, their first name or last name, who has never made a payment. Now, what's another way we could confirm this? Well, I could confirm this by taking a look at the distinct customer IDs in both my customer table and my payment table. So this alone basically tells us that there are no rows that are completely unique. Essentially, there are no customer IDs that are completely unique only to the customer table or only to the payment table. If we have information on a customer, it's because they've done some payment in the past. And we're able to select this with a full outer join and then filtering to make sure that there wasn't anything unique only to one of those tables. And to confirm this, just so we can wrap our head around this idea, let's go ahead and just count the distinct customer IDs from the payment table. So if I run this, there's 599 unique customer IDs or distinct customer IDs in my payment table. And if I take a look at my customer table, refresh this, there is also 599 distinct customer IDs. Now, technically, this doesn't fully answer the previous privacy compliance policy because there could possibly be different ID numbers in different tables. The real way to answer the previous question to make sure there wasn't any customer information that didn't have payment information was using that full outer join and then filtering an additional where with the null statements on those unique identifiers for the customer ID and payment ID. This technically by itself only further validates that last query we did, but doesn't actually fully answer the question. Because technically there could have been maybe customer IDs that were letters in one table that were 599 unique letters or a series of letters, and then the other table could have 599 unique numbers. So keep that in mind. While this does clarify and verify what we did, it doesn't 100% confirm that privacy policy. The only way to do that was using that full outer join with the additional where that we just saw. So we're learning about really powerful tools here, and so far we wouldn't have been able to answer those sort of questions without learning about the different join capabilities. Okay, so coming up next, we're going to learn about a left outer join, which is typically the join that usually trips up beginners, but we're going to take it slow, and once you really get the hang of it, especially with those Venn diagrams, it shouldn't be too bad. Thanks, and I'll see you at the next lecture.